Let's take a look at this electricity question, question number 7 from this November paper. The battery in the circuit diagram below has an internal resistance R. The ammeters and connecting wires have negligible resistance. Both switches S1 and S2 are closed. The reading on the voltmeter V2 is 18 volts. So this is 18 volts. And the power dissipated is 12 watts. So the power dissipated by R, so that's 12 watts. So question 7.1 says calculate the, and 7.1.1 calculate the resistance of resistor R. Now, what I would like to do, and the way I prefer to solve these questions, is I want to write down the information that I know about resistor R. So 7.1.1, I know the power is equal to 12 watts. I know the voltage is equal to 18 volts. Now I go through the different equations that we've been given for power. We've been given power is equal to V times I. We've been given power is equal to I squared R. We've been given power is equal to V squared over R. Now I want R. And so I'm going to use the equation power is equal to V squared divided by R. So I'm going to substitute now. So 12 is equal to 18 squared divided by R. Then switch the 12 and the R. R is equal to 18 squared divided by 12. And that means R is equal to 27 ohms. Now you'll get a mark for formula, you'll get a mark for substituting, and you'll get a mark for your final answer with the correct unit. So I'm going to write that in here, 27 ohms. Now the next question, 7.1.2, reads calculate the reading on the ammeter. So the ammeter is reading the total current of the circuit, right? The current has not been split, it's only being split in these parallel branches. So now what we can do, if we want to work out the total current, the easy way would be work out the current in the pink branch, work out the current in the blue branch, and then add them. So let's go ahead and do that. So the current in the pink branch, 7.1.2. So current in the pink, so I in the pink branch. So that's what we want to work out. What information do we know? Well, we know the voltage for the resistor R, and we also know the resistance. So we can say I is equal to V over R. So it's 18 divided by, the resistance is 27. So 18 divided by 27 gives us, give me a second, 18 divided by 27 is 0.67. Okay, then we work out the current in the blue branch. So current in the blue branch, that's going to be I is equal to V over R. Now remember, because the resistor in the blue branch and the resistor in the pink branch are connected in parallel, the voltage across them is going to be the same. So the voltage is going to be 18, resistance is 12. So 18 divided by 12 is 1.5. And now if you want the current in the green branch, which is the total current, so I total is going to equal 0.67 plus 1.5, which is equal to 1.5 plus 0.67 is 2.17 amperes. Okay, so this is 2.17. Now let's calculate 7.1.3. 7.1.3 reads, calculate the potential difference across the 10 ohm resistor. So the potential difference across the 10 ohm resistor, the V value, we can calculate by saying V is equal to I times R. We know the resistance is 10, And we calculated the current in the previous question. The current is green, is the green branch. You can see that the current has not been split, and so the current that's going through the green branch, or rather the current that's going through the 10 ohm resistor, is 2.17. And that's going to give us 21.7 volts. Now 7.2, when S1 is opened, the reading on the voltmeter V1 changes to 41.9 volts. Calculate the internal resistance of the battery. So when switch 1 is opened, there is no current flowing through the circuit. So when S1 is opened, there is no current. And so it's important for us to remember that the reading on the voltmeter when there is no current in the circuit is referred to as the EMF. So this is going to read the EMF. So in other words, the EMF of this battery is 41.9 volts. Now we can use that information to calculate the internal resistance of the battery. There's a few ways we can do it. Now the way that I'm going to do it is as follows. So I'm going to calculate the voltage that's being used up in the external circuit. So the voltage in the external circuit is the 21.7 plus 18. Remember, in parallel, we only add the voltage once. So 21.7 plus 18. And that's going to equal, so 21.7 plus 18 gives me 39.7 volts. So what is this? This is what the components in the circuit are using up. But remember, the battery has an EMF of 41.9. So there is a shortage. So that shortage is called lost volts. So we can use the following equation. We can see that the EMF of the battery is equal to V external plus the lost volts. So the 41.9 is equal to the 39.7 plus the whatever was lost. And it's lost because of the internal resistance of the battery. So the lost volts is going to equal 2.20 volts. Now there is an equation for lost volts. Lost volts is equal to I times the internal resistance of the battery. So when the switch was closed, the current was 2.17. We worked that out. So 2.2 is equal to 2.17. So now that's the current when the switch was closed. We worked it out, multiplied by R. And so then the internal resistance is going to be 2.2 divided by 2.17, which is 1,01 ohms. Now the last question, question 7.3, switch S2 is opened. So this is now gone. And it's now all green. Will the reading on the ammeter increase, decrease, or remain the same? Give a reason for your answer. So what's happening? We are removing a resistor in parallel. That means the total resistance is going to increase. If the total resistance increases, the current will decrease. So the ammeter reading will decrease, and that's because the total resistance increased. Thanks so much for watching.